Good morning. I am Devi Abhirami. Today I am going to present a problem, Introduction to Linear Programming problem for graphical method. In my previous video, I have taught about the graphical method by using corner point method. First, what is meant by graphical method? For graphical method, there are some algorithm. Our algorithm is first we have to formulate the problem in the procedure of an LPP model. And we have to change our inequalities as equalities. We have to plot our constraints into an equations. We have to identify the feasible solution, locate the corner points of the feasible solution. We have to calculate the objective function. The objective function may be bounded or unbounded. We have to choose the point where the objective function has an optimal value. In my previous video, I have mentioned about the corner point method. In this isocost method, the term isocost or isoprofit method provides the combination of points that produces the same cost or profit as any other combination on the same line. This is done by plotting lines parallel to the slope of the equation. To solve this problem, we have to go on with the following steps. My first step is create a mathematical formulation from the given problem if not given. If suppose a case study is given without giving a linear program, without giving in the format of linear programming, then we have to convert that case study problem into an LPP model. LPP model is nothing but it should have an objective function, it should have a subject to the constraints, and it should have a non-negative constraints. Once the mathematical formulation is done, we have to plot the graph by using the constraints. We are plotting the points to find the feasible region of that graph. Now we have to find the coordinates of the feasible region, what we have got in our step 2. Find the convenient value of z, that is the objective function, and draw the line of the objective function. If the objective function is maximum type, then draw a line which is parallel to the objective function line. And this line is furthest from the origin and only has a common point to the feasible region. Or if the objective function is minimum, draw a line which is parallel to the objective function line and this line is nearest from the origin and has at least one common point to the feasible region. Now get the coordinates of the common point. What we find in step 5, this point is used to find the optimal solution and the value of the objective function. Solved example is given by using an isocost or an isoprofit method. My problem is max z is equal to 50x plus 15y. My constraints are 5x plus y less than or is equal to 100, x plus y less than or is equal to 50, whereas my non-negative restriction is x greater than or is equal to 0 and y greater than or is equal to 0. Now I am going to find the points for this equation. For that, I am going to convert this inequality into equality equation. My equation will become 5x plus y equal to 100. Similarly, my second equation is x plus y is equal to 50. By the algorithm, I am going to substitute x is equal to 0 in my first equation so that I will get my point as 0, 100. And when I substitute y is equal to 0 in my first equation, I will get x is equal to 20. So my points are 0, 100 and 20, 0. Okay. Similarly for second equation, first I am giving the value as x equal to 0 and y is equal to 50. And similarly y is equal to 0 and x equal to 50. So my points are 0, 50 and 50, 0. Now I am going to plot these values in my graph. So my points are 0, 100, 20, 0, 0, 50 and 50, 0. I plotted my graph and I am going to mark the corner points of my graph so that I can find my feasible region. What I have shaded in green color is my feasible region. So to find the objective function, my equation is 50x plus 15y is equal to 300. I'm going to solve this equation to find my exact corner value. So my optimum common point is 12.5 and 37.5. This is the corner common point of my feasible region. Now I'm going to substitute that value in my max z so that I get my answer is 1187. So the maximum value z of the given constraint is 1187. This is how we have to calculate isoprofit method by using a graphical method. Thank you.